Hello, welcome to another episode on Arithmetic and Geometric Series Homework. These are questions extracted from exercise 1i. So for the first question, we first determine if a series is arithmetic or geometric, and subsequently find the sum. For the first one, if I change the first fraction to 3 over 15, then you will notice that the top number, the numerator is just being added by 5. In other words, these are all plus 5 over 15. So that makes it a arithmetic sequence. And the formula will be S7 equals 7 over 2 times 2u1 plus n minus 1 d. Plugging that into the calculator will give us okay, I'm going to simplify some of these because I don't want to type in those fractions. 8.75. Second one. So if I replace, so just write down a few terms here. The first one is 1 half times negative 3 to the power of 1. 1 half times negative 3 to the power of 2. Dot dot dot. 1 half times negative 3 to the power of 8. So the first one will just be minus 3 over 2. Next one will be 9 over 2. So maybe I should have written down one more here. But in any case, it will have been like this. And I don't even need to know the last term actually. Okay, so I'll just leave that out. What I'm interested in is this here. So it's the same as multiplying the top by negative 3. So that would be our common ratio. So that means this is geometric. Oh, I should actually label each one. First one is arithmetic. Second one is geometric. So for our sum, I can write as 8. There are 8 terms because it goes from 1 to 8. So our sum formula is the first term, which is minus 3 over 2, bracket r to the power of n. So this is r to the power of n minus 1 over r minus 1. So this time, just to be extra careful, we will input it the way we have written it. Okay, it takes a bit of time, but it's worth it. This should be 8. And voila, 2460. And then we have C. So you should be able to see that this is just times 0.5. If not, go ahead and just divide the second number by the first to find the ratio. And then check the third term divided by the second term. And yes, they are common, so I can conclude that this is a geometric sequence. So again, we have 8 terms. Start off at 0.1, ratio is 0.5. And then again, we will just put this in the calculator. Ta-da! You're welcome to just write down 0.199, 3 sig fig. And this is geometric. Fourth one, if you do times 2 times 2, you will see that the second times 2 doesn't work. So this is plus 6 plus 6 plus 6. All right, what's different about this sequence, this series rather, than A, B's, and C's? Well, I don't know how many terms there are. So remembering that we can actually find how many terms are there by taking the last term, subtracted by the first term, divided by the common difference, and remember to add one more. So this should be 48. Yeah. So 48 divided by 6 plus 1 is 9. I'm not doing it right. 9. So now I can do this arithmetic. S9 equals n over 2 times. Now because we have the last term, so why not just use first and last term? So then this is 4.5 times 294. 1323. Find out all the multiples of 4 between 1 to 999. So if I write down the first one, and the second, and the third. Now I know 1000 is a multiple of 4, so if I just count back 1, the last number should be 996. Now the problem is, are there exactly 250 or 249? You should know that there should be 249 because the 250th multiple of 4 is exactly 1000. And we started counting at the first multiple of 4. But if you're not so sure, again, we can use the same idea in part D to figure out how many terms are there. So we do last term minus the first term divided by the common difference plus 1. And then this will map to 249. There. So go ahead and plug in. S249 equals 249 over 2 times 4 plus 996. And then 4 plus 996 is exactly 1000. So here's the total sum. And then finally for F, again we have a summation, so I would just substitute n equals 1, n equals 2, and maybe n equals 3, just to see what sort of sequence I have. So here this will be to the power of 0, so that would be 1, so that's just 2. The next one I'll have negative 4. And then if I continue on, this will be positive 8. So you see this is going from positive to negative. So that means my common ratio will be times a negative, and in this case it's 2. And then also this geometric. And we're taking the sum of the first 6 numbers, so we would just write S6 equals U1 times R to the power of n minus 1 all over R minus 1. So be very careful when you are inputting this in the calculator and remembering the brackets for negative if possible. There are some instances where they don't matter if you put them in or not, but there are some where it does matter. Okay, so that's the answers for 1. Moving on to 2, let's So we have theater with 30 rows of seats. So it looks like the fan shape here, right? So with theater, let's start off with 22, 26, 30, ... So there will be 30 of these rows. So as simple as doing 22 plus 26 plus 30 for 30 terms. So I would just use S30 from the arithmetic series formula, n over 2 times 2 u1 plus n minus 1 times d. Because it's expanding by 4 more seats per row, and too lazy to fish out the calculator. Okay, so don't trust me. Make sure you check that with the calculator. But if this is like a paper one question, then yeah, please trust me. Oh, that was simple. Okay, every human has 2 biological parents, 4 biological grandparents, 8 biological great-grandparents, blah, 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 blah. So in terms of sort of like the ancestry line, you know how you have your great-grandparents will have, well, I mean, this is your grandparents, then this will be your parents, I mean, well, that's not your parents, otherwise that would be incest. What I mean is, if you move up the family tree, you will see that it will double after every generation. So then that means if you continue down the chain, there are going to be 1, 2, 4, 8, etc. They don't always only have like 2 kids, right? But we were talking about in this scenario here, going backwards. So after 6th generation, how many ancestors would you have altogether? So make sure you understand what this mean. So that means you're on the 7th level, right? The last 6 generations. In that case, what you want to do is you want to have, so if I just write it down, there'll be 16, 32, and 64. So this is your level. Your level. So all am I doing is I'm just actually adding all these levels here. The first one actually shouldn't be 1, but it should be 2. So let me just fix these. Top level should be 2, followed by 4, 8, 16, 32. And this is the 7th level because you want 6th generation before. So I mean, these numbers are simple enough to just add them up. Or you could always just do S6 equals U1 is, so the top level is 2, n over 2 times 2 U1 plus 6 minus 1. Oh, no. This is geometric, my bad. No wonder I did 2 first. So this U1 times r to the power of n minus 1 this should be 62. Nope, something doesn't seem right. It's 64. $126. So if you were to count your parents, each of your parents will also have their parents, which also have their parents, and then it just branches off in groups of 2. So my diagram is actually wrong. My diagram should have been the other way around. Okay. Yeah, let me redraw the diagram. But basically, it still makes sense. Makes sense in terms of the number. So I should have written this U, and then you have, well, sorry, that was me, but you could be this here as well. And then you will have a biological dad and a biological mom, which has a biological dad and a biological mom, which is your grandpa and grandma. So you see, we're just moving up the chain here. Okay, so this is our last generation. So I guess you can say first generation back, and then second generation back, and then you just want to do it for sixth generation back. And then you should see that there will be 2, 4, let me complete this. 2, no, I was right before. 2, yes, you don't want 4 parents. Okay, 2, 4, and then 8, 16, blah, blah, blah. And then by the 6th generation back, you should have 64 of your ancestor. So, and the last one. So you're making these boxes with matchsticks or just line segments. So here in the first picture, it will consist of 1, 2, 3, 4, and a 5th. So 5 figures, 5 sticks. And if I continue with this picture here, I'm just adding 3 more here. Oh, sorry, 1, 2, 3, 4 more here. So this will be a 6, 7, 8, and 9 stick. So every subsequent picture, you're just putting 4 more to elongate that fence or that picture here. Well, not plus, but and so forth. And then here we want to find the total number of line segments in the first 48 figures. So we actually want to take 5, add to 9, add to 13. So you want to do that for 48 pictures, 48 terms. So we just use the arithmetic sequence series formula. N over 2 times 2 U1 plus N minus 1 times D. Because we're adding 4 more sticks every figure. And again, I'm too lazy to take my calculator, so please don't trust me. 47 times 4 is 188. This is 198. What I can do is I multiply by 200 first and then take away 48, which is this number. But just to put it into the calculator and make sure, 24 times 10 plus 47 times 4. Good. So that's a lot of matchsticks. You will need at least 5 boxes for those big boxes that comes in thousands of matchsticks. Okay, don't ask me why I know. I just do. Okay, and that's it. Hope you enjoy it.